In this video, we are going to study Laplace transform of periodic signal. So for a periodic signal, Laplace transform can be obtained as x of s equal to 1 upon 1 minus e raised to minus st into x1 of s. So here x1 of s is important term. This x1 of s is the Laplace transform of the given function over a single period. So this x1 of s is equal to integration from 0 to t, or it may be from minus t by 2 to plus t by 2, x of t into e raised to minus st, which is the basis function for the Laplace transform, into dt. So let us take a simple example. So let us have a simple square wave of which we need to find out the Laplace transform. So this particular waveform is periodic in nature. So first of all, we need to write down the equation for Laplace transform of periodic signal. So it is given as x of s equal to 1 upon 1 minus e raised to minus st, this t is capital, into x1 of s, and this x1 of s is nothing but the Laplace transform over a single period. To find out this Laplace transform, we must know the period of given signal. So period t equal to, for the given signal, this period, this waveform starts at 0 and ends at 2. So period is 2. Therefore, we can obtain x1 of s equal to 0 to t x of t e raised to minus st dt. So let us substitute all the values over here. Integration from 0 to 2, x of t is nothing but the given waveform. So this waveform has value 1 for the interval 0 to 1, and it has value minus 1 for the interval 1 to 2. So we need to split up this integration from 0 to 1 and 1 to 2, and then we need to evaluate this integration. So for 0 to 1, x of t is 1 into e raised to minus st dt. From 1 to 2, x of t is minus 1 e raised to minus st dt. So let us further simplify it. So integration of e raised to minus st is e raised to minus st upon minus s with the limits 0 to 1. Now here we have minus 1, so we can take minus sign out of integration, and the remaining integration for e raised to minus st is e raised to minus st upon minus s with the limits 1 to 2. So let us simplify it now. So e raised to minus s, t is 1 minus e raised to 0 upon minus s minus, so this is our first term, and in second term we get e raised to minus 2s minus e raised to minus s divided by minus s. So let us simplify it further now. E raised to minus s minus e raised to 0 is 1. So both the denominators are minus s, so let us combine all the terms. So minus e raised to minus 2s, minus minus becomes plus e raised to minus s whole divided by minus s. So further we get the simplified version as, so here we have plus e raised to minus s and e raised to minus s. So here we can write it as 2 e raised to minus s minus 1 minus e raised to minus 2s whole divided by minus s. So at denominator we have negative sign, so let us multiply this, or let us take negative sign common from the numerator. So our equation becomes, minus sign is taken common, so 1 plus e raised to minus 2s minus 2 e raised to minus s upon minus s. So our x1 of s will be equal to 1 by s into 1 plus e raised to minus 2s minus 2 e raised to minus s. So this is not the final answer. Here we have obtained only x1 of s. Now we need to substitute this value in the equation of x of s. So here x of s is equal to 1 upon 1 minus e raised to minus st into x1 of s. So let us substitute this value. So 1 upon 1 minus e raised to minus s t. So it is 2s. Value of t is 2 into 1 by s into 1 plus e raised to minus 2s minus 2 e raised to minus s. So it is 1 by s the numerator term will be 1 plus e raised to minus 2s minus 2 e raised to minus s divided by 1 minus e raised to minus 2s. So this will be the final answer for our expression. So to summarize, a periodic function was given and we were supposed to find out its Laplace. So equation is written, and in this equation we need to find out x1 of s, that is Laplace transform of given signal over a single period. So we have integrated it over a single period and then substituted this x1 of s in the equation of x of s and obtained the final answer.